Great. So now we have this ideal gas thermometer, and out of this ideal gas thermometer also comes out the ideal gas law, because we can take our interpolation here, our linear interpolation, and the slope of this line. Let's draw it in degrees Kelvin instead of in degrees Celsius. So we have now temperature in degrees Kelvin. We have the quantity F of T here. We have an interpolation scheme between 0 and 273.16 with two values for this quantity, and we have a linear interpolation. That defines our temperature scale, our Kelvin temperature scale. And so the slope of this thing is F of T at the triple point, which is this point here. This is the temperature of the triple point of water, divided by 273.16. That's the slope of that line. Right? The quantity here, which is F T at the triple point, divided by the value at the x-axis here. Okay. And so that's the slope, and the intercept is 0, so the function f of t, you just multiply by t here. Right? This is the slope. Okay, now f of t is just the limit as p goes to 0 of p times v bar. And so now we have this quantity, p times v bar, and the limit of p goes to 0 is equal to a constant times the temperature. That's a universal statement. It's true of every gas. I didn't say this is only true of hydrogen or nitrogen. This is any gas because I'm taking this limit p equals to 0. Now this constant is just a constant. I'm going to call it R. Okay, I'm going to call it R. It's going to be the gas constant. And now I have R times T is equal to the limit p goes to 0 of p v bar. It's true for any gas. And if I remove this limit here, RT is equal to p v bar, I'm going to call that an ideal gas. So this is the property of an ideal gas. What does it mean, ideal gas? It means that the molecules or the atoms in that gas don't know about each other. They effectively have no volume. They have no interactions with each other. They occupy the same volume in space. They don't care that there are other atoms or molecules around. Because that's basically what you do when you take p goes to 0. You make the volume infinitely large, the density of the gas infinitely small. The atoms or molecules in the gas don't know that there are other atoms and molecules in the gas. And then you end up with this universal property. Right? So gases that have this universal property, even when the pressure is not 0, those are the ideal gases. And for the sake of this class, we're going to consider most gases to be ideal gases.